Then today we will talk about the two main analysis, social media mining. One is the influence measure or influence, and another one is the recommendation. So first, I asked my PhD student, Harley. He is also the student in my class, but he is doing the research on the influence measurement in social media data. So he will be much better than me. So thanks so much for coming. And
thank you very much. Hi everyone. So, the beginning, I just want to ask you: can anyone define what influence is? Can anyone tell me what influence is? What does influence mean?
Factors impacting something.
Okay, so things that affect other things, right?
To take some action or some decision.
Okay, so to make a change, for example, to change somebody. What about homophily? Did anyone hear about this concept?
No.
similar.
Similar.
Homo means the same.
Homogeneous.
So I think this is from a different field, but they are using it in social media mining. So in the beginning, social networks now are using social forces to connect people. These social forces can be, for example, influence, homophily, other kinds of things that make us connect. For example, in Twitter, when Twitter started, they used influential users or popular users to attract users to use Twitter. I don't know if you heard about that. So social forces are very important because these are the things that connect us through social network. So as you mentioned before, the homophily is the social similarities between us. It's the similarities, how two people are similar. So why is it important to find how two people are similar? So we can actually connect them together. For example, in Facebook, if there was an idea that no one has friends, so Facebook will not be popular, right? Because no one will use Facebook. The same idea for Twitter. So one of the concept is assortativity. Assortativity is actually the social forces. Is the influence, homophily, other kind of social phenomena that we use. So friendship networks are example of this kind of network. Friendship is just like in Facebook, when someone has friends, the other user. How are we connected? We use graph theory, like Professor mentioned in the last class, to represent our friendship. So in the beginning, influence, like the student just said, it's just the process of which individual affect other individuals. Affect other individual to, for example, we can say that your mother can influence you, for example, to cook better, right? It's an influence. Well, maybe some women force them, but so influence is very important. Why is influence very important in social network or in life? The influential people, like even in political and even everywhere, we can use them to influence majority of people. For example, Obama, he became president because he was able to influence many people, right, to vote for him at least. Homophily, on the other hand, homophily is how people are similar to each other. For example, if I like pizza and Muhammad like pizza, so we are kind of similar. So social network use homophily to connect people. Look, for example, gender, ages. Confounding is another concept. Confounding is how the environment, the external environment, forces to be similar. For example, people from New York tend to be similar. This is just natural, right? So confounding is how external environment affects us. So in this small graph, we can see the connection, which are in social media, for example, follower, friendship, and similarity is how two people are similar to each other. So we can see that influence is actually derived from connection to similarity, saying that, for example, as you said, you can change something, right? So if I can influence you, for example, you are taking this class with Dr. Lee. So if Dr. Lee can influence you to like data mining. Maybe before he didn't do anything about data mining, but now you can know. So you are similar with Dr. Lee because now we are all like data mining. The other thing, similarity drive people to connection. For example, you see in Facebook, you always see suggested friends, right?
Yes.
Suggested friends. So they try to find similar things between people to suggest friends. So similarity can drive connection. Confounding is derived from both. How environment affect you, and how can similar affect that.
So influence and homophily is not separated. It's like the circular fashion. It can make the more stronger community by taking a turn. Okay.
Exactly. And assortativity, as I said, is a social forces. It's influence, confounding, homophily. So as we can see here in this graph, in the first one, we see that as I said before, as I said in the previous slide, an influence, we assume that people are already connected, right? So then we can say that from this user, and you can see if we assume that the gray users are one type and the white nodes are another type. So if this user influenced them, so he will turn out to be similar to them. Homophily, as I said before, similarity drive to connections, to drive to connect users. So in the first graph, we see that the users are not connected. So the social network, Facebook, Twitter, try to create this from suggesting friends to each other or followers or anything like that. So they are, as the professor just said, they are not the same thing, but they are based on each other. For example, this example, I think this is in England, if I'm not mistaken, Plymouth. So and this study shows that 60% of teenagers under 16 years old smokes in this city. So influence, we can say that smoker friends can influence their non-smoker friends to smoke, right? However, homophily, smokers, like if I smoke, he smokes, we can actually be friends. Confounding is there are a lot of places that people can smoke. Like in this picture, we can see them sitting in the bar. So we can say that this environment, because we cannot smoke inside, so they go to this place to smoke.
The confounding is kind of environment of that friendship or whatever. So it's important to understand what caused the compounding to make the similar the communities.
Exactly. So the first thing is assortativity. Assortativity is the forces that makes us connected. For
Kind
example,
of power of the community or the power of the social network. So,
for example, in this example, this is a study that was done in 1994 by one scientist. I think he was in psychology, not in computer science.
I think so.
I'm not mistaken. So he went to an actual school that has 4 races, that has white people, African American, Hispanics, and I think other group that could be Asian or. So he tried to observe how they react to each other. So what he found is actually when he draw them and observed their reactions and everything, he actually saw that when he draw graph, he saw that white students stick together, African Americans stick together, Hispanic stick together, which actually is
Natural.
natural, right? Because they are similar in
It's
some
kind
way.
of animal instinct, right?
Yeah.
Yeah. I don't think the bird loves the lion, right? So it's natural.
So actually, I'm not gonna get into details in that, but in order to measure influence or any kind of this, we have to convert the social network to one kind of form. For example, matrices. Efficiency matrix is very famous. I use it all the time to represent my social network. And you know, matrices are easy, not easy, but they make sense. So you can actually manipulate them, use equations to get some knowledge from them. For example, the number of friends, the number of that. So in this, he's trying to measure assortativity using this equation.
Actually, what I tried to mention about from the previous one, this one, is the not the importance of that equation itself, but you can explain. So assertivity is the kind of sum of the connection. You can explain informal way, but you can use the simple the math equation using the canonical data function. What is a canonical? It's very popular, but it's nothing but if it exists one, otherwise zero. So if you see the function used in the sigma function, so if you times the canonical data function, in case of zero, it's a zero. Okay, it's just count, right? If it has the weight, you can add the weight function or any other attribute. So you can make the formal definition of the measurement. That's your job need to do when you are doing the research. But many of the students forget about such a thing. Sometimes you may not realize importance of your research by defining. But if you define your idea with the formal, the math equation, that will be perfect. Okay, so nobody can argue about this one.
So assortativity significance is, see how I think variance from how significant is the assortative relationship between two groups. For example, in this example that shows that if one school has only two races, white and Hispanic, so the expected only 50% of the connection can be different, since we only have two races, 50 students, for example, white, 50 students Hispanic. The wider we have or the larger we have, the more significant we have. And this is this is modularity equation to measure that.
So modularity is kind of a grouping. Can you measure such a grouping? So if there exists, for example, 3, okay, that will be actually the subtract, that will be higher or something. So modularity, such a subgroup can be measured using such an equation.
So I think this is, as Professor mentioned to us in the beginning of this class, or the beginning of the semester, about covariance, how two variables change together. So how much they are like depending on each other, for example. So there is one measure here that is used that's used to measure the covariance between two values. It's using the x left and x right. So I think, from what I understand, that the x left is just to represent the relationship from the left node to the right node, from the x right from the right to the left node. So if we can see from this example, so the xl vector that represents the relationship from the left to the right. So we see that in this H we have the first one A to C, so 19, A 18. Then we have C to A, 21. Then we have C to B, 21 because of this. Then we have 20. Then the same thing for the X R, just we go from right to left. Then using this question, we can see how much they are covariant with each other. So, as Professor before, sometimes you need to normalize to understand, because for example, if you have 1,000 friends but you don't have any posts, so you cannot be compared to someone who have 1,000 friends and has 10, for example, tweets. So correlation is to measure how two variables are correlated to each other, or how to rank. For example, Pearson correlation I've used in my research is to correlate between. It can be used for many things, but how I use it is I correlate between two rankings of users. So if there is if the two rankings are very correlated, so we can see that this ranking and this ranking algorithm produce the same result. So they may have the same effect. So now to social influence. Social influence is, as you all mentioned, it's the act of producing an effect without external exertion of force or direct exercise of command. So it's not like someone is forcing you to do something. Just he's trying to affect you. Actually, to make a change, this is another topic. Is how you use forces to influence people. Because some influence, you don't have to change someone. You just need to affect him. You know, because changing someone is much bigger issue than influence. So how we measure influence? There are many ways to measure influence. There are two famous ways. The first one is the prediction, and the second one is the observation. In prediction, we try to see each user's attributes. For example, number of friends or number of posts. For example, to see how influential he can be in the future. For example, in the last lecture, Professor explained about centrality analysis, how much a user is central, right, in the network. You see when he draw that, when we saw the graph, and we use degree, for example, centrality to see how that shows the importance of user as his number of followers. On the other hand, and the observation-based measurement is to try to observe how can we quantify the influence of individual by measuring the amount of influence. For example, in Twitter, many researchers are trying to measure influence by see how much the information spread out in Twitter. For example, for retweet, right? When you retweet, the information is spreading, but it's not just retweet. For example, when you retweet, his friends will see the tweet, right? And when he retweet, his friends will see the tweet. It's not just the number of retweets. It's how much it diffuses or spread over the internet or over Twitter. And this is a very important topic, actually. So this paper is mentioning one case study about. I think this is a paper that I've read before. This paper tries to measure the influence on blogs. Blogsphere is just a website for blogs. And actually, before I get into this, I read in one paper that one website, one Blogsphere website, his number of visitors reduced dramatically when one of the influential users went for a vacation for 2 weeks. He didn't write, so the number of users reduced. So this guy now he decided to pay the influential user to keep writing in the blog. So the goal of the measuring influence is to see to figure out the most influential users on that. For example, I just mentioned like if he left, the number of visitors have reduced dramatically. Because in blogs or in tweets, just remember that the content is driving the whole thing. Without content tweet, nobody's gonna use Twitter, right? If you don't have any content going on, and who generate the content is the users. So we have to see how users are generating. How can we differentiate between the influential user and the regular user? This is not like a mass media. The journal or the newspaper or the channel controls everything. No, it's actually social network and social media is controlled by everyone now. Like for example, in YouTube, if you can see now, the influential user get paid from YouTube when people view their videos. You know that? Or, I don't know if you know that, but influential users on YouTube now, they are getting money from YouTube.
Oh, really? Yeah.
A lot of money.
Yeah. Mm-hmm.
Because they have to pay them to generate content.
Mm-hmm.
At least certificates. They provide also certificates for some users.
Oh, really? And they pay a lot of money. I know that one user get paid like, I think 10 millions each year.
Oh, really?
He's very famous. I forgot his name, but he's very famous.
I'd better
YouTube.
quit my job. Try to make the video lecture.
So, what this paper tried to do, this actually one research tried to find out what are the most influential users in Blogsphere. So they designed a system. It's called iFinder. iFinder considers the in-links. For example, we can think about in-links like in Twitter, for example, people who follow you. They are the in-links, right? And the outlinks is how many people you follow, for example. To measure out how influence is moving in Blogsphere. They want to see what is influence. How can we quantify influence? You know. So they suggested many social gestures. For example, is number of links that. For example, this is the first one is the number of followers. How many followers you have? The second one is the activity generated. For example, this is I used in my research the number of comments that one receives, because if you are receiving a lot of comments or a lot of So we can say this content can be actually high quality or better than other. Novelty. How novel are the topics that he's writing about, I think. And eloquence is estimated by the length of so in this they just try to see if the longer blogs, longer topics or that affect that. So in this equation they try to measure out the influence. As I said before, they subtract the number of following from the number of followers. They did the same thing here. Another paper is try to measure, I think this will make more sense. Another paper, this one, try to measure the social influence on Twitter. I think they use the N degree, which are the number of followers. For example, Katy Perry, she has over 60 million now. Number of mentions, how many a user is mentioned. So they collect the tweets and they see how many someone is mentioned Twitter. And the number of retweets, how many the retweets per user. So this can say that this tweet has diffused a lot, even so it doesn't exactly count that. And I don't think it's written there, but I remember that they found out that actually the number of mentions and the number of retweets, when they rank the users by the number of mentions and the number of retweets, they found out higher correlation between them. So the users who is mentioned a lot in Twitter also has high retweets. So they can actually predict if someone has been mentioned a lot, he would have many posts. And what they found is the number of degree did not really reflect did not really correlate with these two measures, which actually says that if you have 60 million users, maybe you're not that influential. Maybe you're not posting a lot of content, or your content is just tweets are not that significant, you know. So this user, so people just maybe follow Katy Perry because they love her songs, but they don't love what she's posting about. So this is just actually to see how they rank the users according to N degree, mentions, and the number of retweets. And they also use the supreme rank correlation I just mentioned, is to see how much two rankings are correlated to each other. And they found out, as I mentioned, that users who are mentioned a lot have a lot of retweets. So this is just the correlation between them. You see that the retweet and the mentions has 0.638. So as I mentioned, like if we, without even looking at the retweets, if we see that someone is being mentioned a lot, we can actually predict that he has a lot of retweets, according to their study. So the influence modeling, actually this is another problem. This is not just identifying the influential user. This is how to maximize the influence in social network. For example, if you have a tweet, how can it spread out? How can we measure it to spread out over all to Twitter, right? So at T1, as you see, this is user V. This is the user who's generating the tweet, and U is the user who's, for example, one of his followers. So in this time, V is writing or posting a new tweet. So when you read this tweet, this user will, this means that the influence has moved from V to U. And in this kind of problem, they use two kinds of modeling techniques. The first one is they apply on a network with explicit network. Explicit networks means that, for example, we know that we connect people by the following, you know. So we can see that user A has many followers. So we already know the shape of the network. Implicit means that maybe we try to connect the people by, for example, the post. For example, if someone is posting about any event, if we see that this user is posting about this event, so they don't have an explicit, but they have an implicit connection. And for the first one, the explicit, we can observe because, for example, the number of followers or the following relationship, the friendship diagram, it can show that. So we can use actually linear influence model to linear threshold model to model that. And for the other one, for the implicit networks, we can use this linear influence model to model that. So the threshold model just says that when A tweet, for example, what is the probability that B will retweet it, for example, or will see it? So in this diagram, we see that, for example, at step 1, this means at time 1, V has posted some tweet, for example, and there is there is a probability that this tweet has transmitted to this user 0.8 and 0.5 to V3. This is the threshold. So we can say that when this influence amount is bigger than the threshold, so we can assume that V3 has, for example, read the tweet. As you see here, in time 2, you see, because this one is bigger than the threshold, so V3, for example, has read the tweet now. Okay. In the same now, V3 transmitted the influence by 0.1, and this guy has a threshold with 0.09. So this one is bigger than this one. So V4 have read the tweet now, and it's so on, till that, for example, we see that this tweet has spread out from the user who created to here with a probability and threshold. So even this user has 0.5 probability that he will read the tweet with 0.5, but this specify the threshold to be 0.8. So this is very high. So he hasn't. This threshold can be specified by many factors. For example, they can see how two users are similar to each other. So if they are not similar to each other, and he's a direct follower, for example, he didn't read the tweet or he doesn't repost it. So it all depends on the threshold. The threshold, as far as I know, they use it. The threshold they use it randomly in this study, between 0 and 1. So on the other hand, the implicit network, the network that doesn't have a direct connection, for example, following or friendship, they use another kind of model. They just assume discrete time steps, so it's not continuous. For example, in this here, we can see that at time 0, the number of followers is, for example, 1,000. And at time 1, it's not continuous. At time 1, so today he has 1,000 followers. Tomorrow he can have 900 and so on. So they don't assume continuously. So the size of the activated is how many followers you have, for example, at one time. So in this, they use this estimation to measure that. They use two kinds of estimation, barometric and non-barometric. So barometric is just use some distribution to estimate that. For example, the Gaussian or anything. The non-barometric estimation, they just assume that the nodes that get deactivated over time and can no longer influence others. So if no user has read the tweet, he cannot transfer the influence. So the last thing is, I think, homophily. Homophily is how much two users are similar to each other. For example, in the beginning of this semester, Professor mentioned about cosine similarity. This can be used to see how much users are similar to each other. For example, two users who have many common friends, they can be actually similar to each other, even so they don't have a friendship link. So there are many ways to measure homophily. One way is to use, for example, cosine similarity to see how many common friends they have. And in this, they used how the associative network change over time. So they see how influence change over, not influence, how their social force change over time. So they take a snapshot of the network at this time, then they take another snapshot in the next time, and they compare between the two graphs. So homophily we can model it using independent cascade model. The cascade model is, the independent cascade model is just, they measure how tweets diffuse over the network, for example. So I think maybe you got a little bit confused between influence and homophily because they are all related to each other. But there is a big difference, not a big difference, but there is a difference between them. But actually in research, when they try to measure influence or they try to measure homophily, they need an actual statistic test to distinguish between them, which one is influence or which one is homophily. So there are many tests. The first one is shuffle test. Shuffle test is just, for example, in this example, they put 3 users organized by time. And when they shuffle it, when they, for example, they move the user at different times, they want to see if they are changed or not. Meaning that, for example, if I am an influential user who influence you guys, I should keep in the influence in the next time. So if I influenced you at today, yesterday we shouldn't have a relationship because I didn't influence you. But if we are similar, it didn't matter about the time, today or tomorrow, because it can be before or after. So this is the kind. Another type is to distinguish between homophily and influence is to use the edge reverse test. It's just to reverse the edge. For example, if we see that this user influenced this and this, so if we flip out the edges, so the correlation between them shouldn't change. I think that's it.
the last one.
And I think that's it. Thank you very much for listening. If you have any questions, or if you have any
Any question? So I think thanks so much. Influence measure is one of the top research topic in social media mining. So many people are doing the research on how to measure. The problem is how to model the influence. Okay. The first thing is to define what is the influence. Then the model. Model means anyway the definition of the something. It's not the formal equation. So modeling means whether we can make the data structure for such an idea or definition. So simply we can define, if we can define the influential user is the number of followers, right? If that is the definition, we can model the influence as the sum of the number of followers, things like that. But it's not the only one, so we can consider the power of the follower or the degree and so on. So depending on how to model, how to define. Also, depending on the social media data type, it can be different. Like the Facebook is different from the Twitter, and the blogosphere is definitely different from the Twitter. That's the key point. And eventually, we need to think about how much impact the definition of such an influence. If nobody interested of that influence, you don't have to. Nobody, your idea will not be used. So in terms of marketing or in terms of sociology, how we can use such the definition or modeling of the influence, that will be the key part. And so we will see another one today, that is the recommendation. I think that probably you are familiar with the recommendation already. Whether or not you realize when you are using the social media, not only social media data or social media network, but also any website, including Amazon or eBay or even Facebook. So you will encounter, you may see such an application of the recommendation in social media data. So we will see it. What is the goal of the recommendation? Recommendation is anyway. So I think the Khalid mentioned about some of the power user of the YouTube and make the money, big money from the YouTube. YouTube will provide such a money. By what? Because that the user, many of the user watch that video content, and also because of that, there might be another the video that the user interested in, and also through that recommended video, the people will be exposed to the commercial. So sometimes you will see the advertisement, then the couple of seconds later, 5 seconds later, you can skip. But anyway, you are exposed to such a commercial. Sometimes you may be interested. So at that time, the how to recommend. So if they show the non-interesting, the commercial, it may not be used. But if I watch many of the Minecraft, do you know the Minecraft? It's a very popular game. Even every day, my son watch the Minecraft video at least a couple of hours. Then if they know such a pattern, then they can recommend some similar commercial to the user. So the company can use such the recommendation. That is the topic of this another important topic in the social media marketing. So these are the example of the recommendation system using the social media data. This is Amazon. Amazon, sometimes you may be surprised. So when I search the book, it's already recommended because you are not going to select a book randomly. It's based on your interest, based on your condition. For example, if you are taking a course in computer science, you are not going to take suddenly the totally different subject like the psychology or whatever. You are interested in the topics in the computer science. So they already know. Those who watch it purchase the database book and operating system, they probably, most of the people who purchase this one are purchased also computer architecture, for example. So they can suggest it. So usually that works. So that is So that is the recommendation system in Amazon. Similarly, the similar video. So if they recommend randomly pop up the video, probably there is no chance to click it. If the user click some of the related video, they have the YouTube have more chance to expose the commercial, even similar commercial. The eBay is the everyday I receive the email even if I do not log in the eBay. Recently I got the 100 star, so which is the kind of what is the review, good review. So actually I'm longer than this 12, 13 years. 13 almost. I started the eBay 2002, so it's longer than almost 14 years.
Will they pay you like YouTube? Will they pay you for that, like YouTube?
I'm for
eBay, for the 100 stars.
I know, nothing. There's nothing. But one time, I uploaded the video for the Thomas train. You know the Thomas train, which is very popular for young kids. So my son, when he was 2 years old, he played with the Thomas. I took the video. It's several, I think less than 1 minute video. But I don't know what happened, but almost millions of watches that video. Then the YouTube send the mail. So if I do something, they will pay by the number of views. But to do that, I need to promote something like that. But at the time, I didn't. But so if I quit my job, I will try. And you can see such a recommendation in the restaurant or the local business. That's also the good example of the recommendation system. Okay, so I'm not going to use directly this slide, but I'd like to ask you, how can we make the recommendation system in, for example, Amazon or eBay? So if you are developing the recommendation system in the company, how can you?
Frequent pattern recognition.
Frequent pattern? What kind of frequent pattern?
practices.
Based on the knowledge you learned in the data mining techniques, purely example application of the data mining technique. So how can you?
Use a primary algorithm to find the frequent pattern.
So frequent pattern, that is the general, our general goal of the data mining, okay, data analytics. That what kind of pattern you are going to find, suggesting pattern. So you can use association rule mining,
rules,
right? In case this item is purchased, and 70% of them purchase the C item. So that is the frequent data mining and association rule mining you can apply. And any others? What if you can find similar user, okay? How can you find a similar user who are interested in the computer science, and the age is the 20 or 30, okay? And even if you know the location of the residence, okay, that probably affect, okay? And some other user profile information, then you can actually, based on that, if you can find a similar pattern of this user, you know the user A is a very power user of eBay, okay? They purchase this one, you know. So if you can find similar user as A, you can suggest this item, this item, this item. This is possible. So how can you? So you can actually train the purchasing item based on the user. Okay, that's the user base, the recommendation system you can do. Also, you can focus on the item by item. So if you do not, it's not easy sometimes to access the user information. Okay, so you can find the probability, like to think about the, for example, the what is the name? Netflix. Netflix used a lot for recommendation system, recommend the new video, new release of video, what contents. So another way is you can actually use the Bayesian, the naive Bayesian algorithm, or any training, the classification algorithm to train. We have a number of the items, okay, and also we have the number of users. So we can have the big matrix and the train. Then we derive the probability, sum of the high probability of the item when we have the new item, because this user have the probability history of the purchasing or watching of this item, this item, this item, this item. So when we have the new item, so we can predict the such a. So based on the item, so we can think about the roughly the two approaches based on the user. Another one is based on the item. So this is the. But anyway, both of them is based on the to finding the pattern, to find pattern. Okay. So that is the main idea. Actually, the most of the thing, but that's the general approach to recommend the system. But depending on the item or depending on the such a purpose of the business, it may be different. But definitely the recommendation system is different from the search. Search is you can list, okay? You can find, you can select like the database search. You can select the if we have the something attribute like the for each item we have the attribute like or dislike. Like the dislike, we can list search such a item that you like. That is a database search. But the recommendation system is we do not have the truth of that, but we have the probability or predict or recommend or guess. Okay, that is the recommendation based on the history. anyway, it's not easy to recommend it. It's not searchy, so we need to the private, okay? And also data is a sparse. For example, how many video in Netflix? Millions, 10 millions. Then each user, even though power user, how many videos each user can watch a year? 300, 600? So very few. So it's a very sparse data, mostly. Okay? That is another problem. And also the privacy is always the issue. Like if we know all the user information, then we can easily recommend. But that is not easy. That is the reason one of the research in social media mining is the user profiling that the GA introduced before. That is the privacy issues. And even sometimes the company cannot use such a private information. That is the reason Google is really envy the Facebook information. The Facebook, they close because of the security reason, privacy reason, they do not open the user profile information or even friendship information. That's, in other words, that's very important information to the recommend the user. Okay, so I'm going to start the recommendation system. If you are interested in more in such a recommendation system, why don't you study? Not only based on this slide, but you can find many published papers. Okay, why don't you try to read such a published paper and try to understand their approach? Then it will be easier to understand. So after 5-minute break, we will continue for the R programming. I'm going to skip to the. I ask you to do the first part, second part at home. Okay, that we missed. Then we will continue with the visualization. That will be helpful for your also the project. After 5-minute break, and also I need to bring the laptop.
What?